We said that the nth root of a to the m. I'm not sure whether this was the exact handout I used. So you can stop me if, or this one. I'm not sure now. I think it's this one though. Okay. So the nth root of a to the mth power is a raised to m over n. We know that this is the exponential notation with a fractional exponent. So the radical can be changed into that and backwards. This with a fractional exponent can be changed into that. The radicand is, the index is n, it can be 2, 3, 4, and so on and so forth. And under the quantity under the radical is called radicand. And we identified all these. We said that they are odd and even indices. And we simplified each and every one of them here, but we said I cannot say blindly the fourth root of -3 to the fourth is -3. That would be a mistake because we know that even indices require positive answer and cannot be applied to negative numbers. Radicals with even indices cannot be applied to negative numbers. The answers will not be a real number, and we will have to discuss that in at the end. Actually, at the end of chapter, I should not write 11. It is true, it's also in 11, but also at the end of chapter 7 as well. Okay. But it's true, it's also in chapter 11. Okay. Change the exponential expressions with rational exponents into radical expressions. Let's do this. Where are we?
On page 3.
Okay, perfect. Oh yes, of course, we reviewed that. So, and we worked on these problems, right?
I think we got this. We did A.
Okay. Okay, and we worked on rationalizing on both. Okay, we'll come back to more examples. Perfect, excellent. So let's move on. Okay, we did graph one function of these two. So f of x equals the square root of x. Let's graph it again, because then we are going to look at graphing the cube root of x. Okay, so that's where we are at the top of page 4. When we review for test 2, we're going to go over this handout one more time from the beginning and problems from the book. So graphs of radical functions, the square root and the cube root. A radical function is a function. Defined by an expression containing a radical function is a function defined by an expression containing, of course, absolutely, a radical. Find the domain and range. So we'll find the domain and the range from the graph, and I like to graph it. We graphed this before. This is not new. This is new. We have not graphed this before, but we graphed this one. So I have to find the domain of this function. How do I find the domain of the square root of x? What do I have to write? We're not going to be able to finish. The domain first. I just mentioned the domain 3 minutes ago, or less. It's written right here. Radicals with even indices cannot be applied to negative numbers. So what do I have to write? I have to write that x has to be greater than or equal to 0, so that the domain is 0 to infinity. So I can start 0 to infinity. So now let's pick a few values of x. Of course, I have to start with 0. I have no choice. So what will I have when I plug in 0? Perfect. And please give me 3 other numbers that I can take the square root from. Now, this is extremely important. I'm not sure how to make my students, even in calculus classes, for some reason, students don't like the square root. I don't know why. Not sure. We talked about it. I cannot have a negative number under the square root. So this is the obvious thing to write right away. It has to be greater than or equal to 0. So, okay.
2.
I cannot take the square root from 2. 9. And I need one more here. Perfect. So please plug in 1 and tell me what you get. Yes. Please plug in 4 and tell me what you get. Excellent. And please plug in 9. Good. So we know the graph. So 0, 0, 1, 1, 4, 2, and so on and so forth. Here's the graph of the square root of x. Can anyone give us a range? And you see it. It's right here. I graphed it for you. So you can put it in the on a chart on the grid. So what is the range of this function? Thank you. Perfect. Now let's look at the cube root. I have to find the domain of this function. How do I find the domain? What do we know about the cube root? Say it again.
It can be even or
The cube root is odd. We're talking about x now. What can x be? Excellent. There are no restrictions on odd indices. Odd indices are friendly. Everything goes. The inside can be positive, negative, or 0. The outside will be accordingly, positive, 0, or negative. Perfect. So now, let's start the chart. Excellent. Thank you. So from negative infinity to infinity, we have to have 0 in the chart. And please give me 2 values of x to the left-hand side of 0 and 2 values of x to the right-hand side of 0 that I can easily take the cube root from. We had examples on the front page of the handout.
-1.
Excellent.
-4.
The cube root of -4 is hard.
Yeah, that's right.
-9. I can't take the cube root from -9. Very good. Excellent. And on the other side, and of course. So please plug in -8 and tell me what to get. Excellent. Please plug in -1 and tell me what you get. Excellent. Please plug in 0. Okay. Please plug in 1. Please plug in 8. Excellent. Good. Awesome. So let's graph this function. 1, 1. 2, 3, 4, 5, 6, 7, 8. 2. 0, 0. 2, 3, 4, 5, 6, 7, 8. And 2. So please watch for a second. This part kind of looks like x squared. I'm sorry, I meant the square root of x. But there is also this piece. So this is the cube root of x. Can anyone give us the range? You already gave me the domain. Now I would like to look at the graph and say the range is absolutely. As expected, anything goes inside, anything goes outside. Excellent. And you have the graph. I graphed it for you. Of course, the software does not show the arrows. You can put the arrows in if you want. Very good. Okay. Now let's read the next paragraph, which is extremely important, and let's work with it with different problems. Radical expressions are called or considered fully simplified if three conditions are fulfilled. We had an example before. So if I draw your attention for a second here, we had an example before. This one, in which we were given a division and the product in the denominator. We copy the numerator, we copy the base, we edit the exponents, then we had to subtract from the power of the numerator. I subtract the power of the denominator, and I have 1/3 minus 2/5 minus 1/2, and then I continue by finding the LCD, adjustments for the top. I get this. Negative exponent, not allowed. I change it into 1 over x to 17 over 30. Then I can have a radical in the denominator. So I had to rationalize. So these are the steps. There is one step that we did not encounter yet. So there are no negative exponents in the final answer. Yes, that's one. There are no radicals in the denominators. Yes, that's another one. We have not encountered this one, and I will explain it in a minute. The exponents under the radicals are numbers smaller than the index of the radical. So the exponents on some base, right, found under the radicals have to be smaller than the index. So what I'm saying here is this. If I have the square root of x to the third, because the power or the exponent is larger than the index, this has to be simplified. If I have the fifth root of x, I cannot simplify it. This is fully simplified. It complies with all three conditions. No negative exponents, no radicals in the denominator, and the exponents are smaller than the index. The exponent is 1, index is 5. So this complies with all three conditions. This one does not. So this one complies with two conditions, not the third one. Okay. Because of that, I will have to split the power or the base, or the exponential notation, into two bases, both the same, of course. How do I know what to choose? So in my mind, I do 3. What do I do with 3 and 2? What is the operation? Front cover, the first thing we did in this chapter. Top. What do I do? Yeah, exactly, excellent. So in my mind, I say 3 divided by 2, but 3 divided by 2 is not an integer. I go back 1. What about 2 over 2? 2 over 2 works. So I'm going to say 2 and 1. So I break 3 into 2 plus 1. So x squared times x to the first power, I copy the base, add the exponents, and I get this. It's a product, and I can split it like this. Let's assume for now that x is positive. What does this represent if x is positive? Excellent. Times the square root of x. Now, this radical complies with all three conditions. The exponent is 1, the index is 2. No one can further simplify x the square root of x. No negative exponents, no radical in the denominator, and the exponents of these quantities or quantity under the square root or the root, the exponent is smaller than the index. Excellent. Okay, so let's work on this problem. So x to 1/4 divided by x to 2/3. I copy the base. What do I do with the exponents? When I divide, I copy the base. What happens to the exponents? Yes. From 1/4, we just reviewed that example, right? I subtract 2/3. Perfect. What is my next step then? Excellent. Which is adjustments for the tops. Excellent. So 3 minus 8. Very good. Excellent. So I copy the base, and I have -5/12. What happens next? Say it again.
Can we go back? How did you get the 3 and the 4 for the numerator? 1/4 and minus 2/3.
When I subtract 1/3 from 1/2, I have to find the least common denominator, which means I have to change this into 3/6. Have to change this into 2/6. So instead of writing two fractions, I use one fraction line, and I write here 3 and I write here 2. But you don't have to use this method. Just forget about what I wrote. On the side, subtract 2/3 from 1/4.
Okay.
Good. What happens next? Excellent. 1 divided by x to 5 divided by 12. Okay, perfect. Now what? What does x to 5/12 mean? It's the 12th root of x to the 5th. Very good. So now I have to multiply by the 12th root and divide by the 12th root. I want to rationalize the denominator. How do I rationalize the denominator? What do I need? How many should I have total? How many x's should I have total since the index is 12 in order to eliminate the radical? 12. How many do I have? 5. How many am I missing? Excellent. So then the numerator is indeed the 12th root of x to the 7th. And what about the denominator? Exactly what we wanted. We wanted it to be x. That's how we came up with the 12th root of x to the 7th. Very good. Excellent. Well done. Any questions? We'll have plenty more. I just want to go through all topics here, and then we'll go back to the book. Okay, so here is adding and subtracting radical expressions. Like radicals, I can only subtract and add like radicals. Like radicals are those radicals with same index, same variables raised to the same powers. Variables are placed in the same position in the radical expression, outside and inside. Only like radicals can be added and subtracted. So I'm going to start with this example. Quite involving, okay? Why? Because it has 3 terms that I have to work on. Not difficult, you'll see in a moment. We'll take them one at a time. Okay. We're not going to do this in general. We're going to work on all 3 of them at the same time. However, I like to take one aside, simplify it, and then come back to the second and come back to the third just for this example. So assume I only have 2a the fourth root of 32b to the fifth. Okay. Now, can anyone tell us what is 32 using a prime number, or the prime factorization of 32? Let's say I don't know. Okay, it's divisible by 2. It's a even number, so it's divisible by 2. Okay, 32 divided by 2 is 16. 16 is divisible by 2, so it's 8. 8 is divisible by 2. 4. 2, 4, and 2 and 2. So I can rewrite 32 as what? Excellent. Excellent. That's all I needed. Perfect. So I'm going to come back to my radical, and I'm going to say 2a, the fourth root. And now I would like to think for a moment. I have here power 5, but the index is 4. Obviously, 5 over 4 is not going to be an integer. So I will have to split 32 into two numbers. Both have base 2. But what about their exponents? Okay, so here's how we do it. 5 over 4 is not an integer. I go back 1. I don't jump to 2. So 5 over 4, no. 4 over 4, is that okay? So then that's all I need. 4 and 1. Now let's look at the b to the fifth. 5 over 4 is not an integer. So I have to break b to the fifth as well into two pieces. B to a power and b to another power. Which powers will I use now? Of course, it's the same thing. I have 5. 5 over 4, no. 4 over 4, yes, and there is a remainder of 1. Excellent. Stay with me, please. So then, if you want, you can rewrite the step like this. Because I know I'm allowed, it's a product. So I split the product of 1, 2, 3, 4 factors under the fourth root into 4 radicals. The fourth root of the first times the fourth root of the second times the fourth root of the third times the fourth root of the fourth. So far, so good? Everyone? Okay, perfect. So now, which of these radicals will be simplified? Because not all of them can be simplified. For example, this one I cannot simplify because the power is 1 and the index is 4. There is nothing I can do here. So which one or which ones will come out of the radical? So what will this equal to? 2, but I have to multiply it by the 2 in front. So I have 4a. So this is gone. Anything else comes out of the radical? Yes, let's assume everything is positive. Otherwise, I would have written the absolute value. So what is this? Good, excellent. This is gone. So now I have to put back under the fourth root what can no longer be simplified. What goes under the fourth root and it cannot be further simplified? Excellent. This is the simplified form of the first radical. Which radical? This one. Now I would like to work on the second one. Ready? Okay, so I have negative 3b. Let's forget about the negative because I know it's going to be negative. So I'm just going to erase this and just write 3b for now. So 3b, the fourth root of 162, a to the fourth b. I like this. I don't have to do anything to it because it's 4 over 4. I like this. I can't do anything to it because it's 1 over 4. But my question is, what do I do with 162? I have no clue. I'm going to take it aside, and I'm going to say, okay, it's an even number. I have to start with the first prime number, which is 2. And then I have 81. And then I know that 81 is divisible by the next prime number, which is 3. And then I get 27. And then 27 is divisible again by 3, and I get 9. And then I get 3, and I get 3. So obviously 162 can be rewritten, should be rewritten. How? 2 multiplied by 3 to the 4th power. Very good. So now I go back. I have 3b, the 4th root of 2, the 4th root of 3 to the 4th, the 4th root of a to the 4th, times the 4th root of b. What is this? 3. What is this? Very good, assuming everything is positive. So what would be the simplified form of this radical? Tell me what to write. Without writing it will be difficult. Just looking may not work. Okay, so 9ab, the 4th root of 2b. So there is a 3, there is a 3, there is an a and a b in front, and the 4th root of 2 times the 4th root of b. Okay, last one. We have the 4th root of 2a to the 4th, b to the 5th. Any questions? Don't you need to write it down? It's when we work on it. Okay. Well, if it works for you, that's fine. Okay. So this is clear. There is nothing I can do to it. This is nice because it's 4 over 4, but this one is not. How do I split or present b to the 5th, keeping in mind that the index tells me what to do with the 5? How do I split it? 4 and 1 the same thing. So this is the 4th root of 2, the 4th root of a to the 4th, the 4th root of b to the 4th, and the 4th root of b. How much is this? How much is that? ab in front times the 4th root of. Very good. Okay, so now I fully simplified each radical. I'm ready to go back to the original problem. So here's my original problem. So from here, I continue here. The simplified form of this first radical is 4ab, the 4th root of 2b. The simplified second radical is minus 9ab, the 4th root of 2b. And the simplified form of the last one is right here, plus ab, the 4th root of 2b. Now we have to look. We have to look and make sure that these are like radicals. If they are not like radicals, we are not allowed to add them or subtract them. So first I look at the radical part. Is the radical the same index? Does it have the same index? Does it have the same radicand? Does it have the same variables in front of the radical? Do they have the same power, all of them, everywhere? So then I could say in my head, 4 apples plus 1 apple minus 9 apples. 4 plus 1 is 5. 5 minus 9 is negative 4ab, the 4th root of 2b. That's it. So coming back to our handout, I would say, yes, these are like radicals. And the simplified form of this is negative 4ab, the 4th root of 2b. Negative 4ab, the 4th root of 2b. Any questions? Any questions? We're going to have plenty more examples. Of course, one example is not enough. I would like to talk now about, it's on the next page, but I need it now. So it's this principle the square root property. You don't have to look at it just yet, unless you want to, because I'm going to write it here anyway. The square root property. Okay. Now, let's suppose I have the following problem, equation. How will you solve this? What would you say? You will say, do this, do this, do that. What? Say it again. Okay, and then what will I do? Well, we don't know that. What we know so far is our contract from the first day of classes. This is what we know, right? And from here, I have x equals 2 or x equals -2. This is what we know. This is what we studied in the previous course, and this is the property of, the special product that we discussed on the first day of classes. This is what we know. I want to present the other method that Heather started with, which is perfect, but I would like to say a few things before we do that. So she said, move forward to the other side. Of course, this is the second possibility. And what do I do next? Say it again. Take the square root or apply the square root to both sides. Okay, stay with me, please. The square root of x squared. I don't have any indication about x. X could be any real number. So look at the left-hand side and tell me what should I write. I cannot. Right. Thank you. Absolute value of x. Excellent. Because I don't have any information about x. If I'm told x is positive, then I will write x. Good. What about the right-hand side? What is the square root of 4? Good. So now going back to chapter 9. How do I solve this equation? What do I have to write? You don't have to memorize anything. You just have to remember how to read it, though. I'm trying to find x value such that what?
X is less than, x equals 2, x equals -2.
Indeed. So this equation, in case, and we will do that, in case we skip this step, do not erase it. Nothing is wrong. I'm just making a point. So if I write the solutions x plus or minus 2, the reason why I always show the intermediate step, at least on the first problem, is because I don't want you to think that the square root of 4 is plus or minus 2. It's not. These two symbols come from here. This symbol, the absolute value, creates the plus and the minus because it's the distance between 0 and 2. So never ever say that the square root of 4 is plus or minus 2. See, if I omit this step, I don't have anything that covers exactly that. Okay? So if I omit this step and I just write directly x equals plus or minus 2, you may think that the square root of 4 is plus or minus 2. Right? I don't want you to make that mistake. So please remember, the plus or minus come from here because I'm asked to find the numbers whose distance from 0 is 2. That's why I get positive 2 and negative 2. They come from solving this equation. So we will do this from now on. In general, if you go back to page 6, x squared equals k. We take the square root, and the result directly, we skip the intermediate step, and we write this. Not to be understood that the square root of k is plus or minus the square root of k. Okay, so now I would like to solve with the same procedure, which is called the square root property. I would like to solve these two problems. So now you can go back here and write x equals, oh, I already have it, plus or minus the square root of k. So now I would like to look at these two problems. And then we go back. So I'm asked to solve this equation. What should I do first? Always remember there are two key words constantly in our minds. What are those two key words that I kindly ask you to remember? What are the two key words that I would like you to always have in the back of your mind when you do any algebra or any math? What are those two words? And one of them is simplify. Very good. And the other one is factor. Factor and simplify are the two most important keywords that you have to remember. So which one will apply here? Will I apply here, you think? Yes, I will simplify both sides by dividing both sides by. You cannot put anything inside. By the order of operations, you have to square first. Yes, we're not going to square. So I have x minus 1 squared equals. Perfect. Now this is a typical situation in which I will apply the square root property. So what do? So I take the square root from the left and the square root from the right. Always remember this is quadratic. How many solutions do I have to have? Quadratic. Absolutely. Good. So then, what do I have to write? I write x minus 1 equals. Good. But if I write 4, I will only get one solution. What did we say we have to write? Exactly. If I forget about the plus or minus, I will not solve the equation. So I will move 1 to the other side, so I get x equals 1 plus or minus 4. Now I have to separate the solutions and write them clearly. What is one solution? Five. And the other solution is? Good. Okay, let's look at the other problem and then move on. 3x plus 5 everything squared equals 20. It will not be a mistake to expand 3x plus 5 and then move 20, but it's not what we want to do. That is difficult. What we're going to do and the method we're going to apply is much easier. So what will I have to do to both sides then? It's already factored. It's something squared. I can't. I can't take anything from inside. I cannot simplify anything. There is nothing I can simplify. So I go ahead and directly to what? Take the square root indeed. So what do I have on the left? Right. But remember, I should have the absolute value of 3x plus 5. Instead, what do? Plus or minus indeed. Let's take, don't write the square root of 20, let's take the square root of 20 on the side. How do I split the square root of 20 so I can simplify it? What times what? Not a sum or a difference. That would be a terrible mistake. It has to be a product. Give me a product of two numbers whose product I should say is 20, and one of them is a perfect square, the other one is not. Say it again. Not the sum. I cannot use the sum because I cannot simplify. I cannot take the square root from a sum and do anything to it. It must be a product. Correct. Perfect. So what is the square root of 4? So this will be 2, the square root of 5. And no one can further simplify this. So this is 2, the square root of 5. How do I proceed? I haven't solved for x yet. What will be my next step? This is linear now. We should have no difficulties with this. Yes, correct. Very good. 3x equals negative 5 plus or minus 2 the square root of 5. Very good. Excellent. And then, final step. Yes?
By 3.
Correct. Very good. Excellent. Thank you. There is no point in trying to simplify this. There is no point in trying to separate it. It does not require anything else. That's it. Okay. Now I would like to go back to page 5 at the bottom and discuss distance formula. Okay, so let's look on a Cartesian system or coordinate system. Let's say I have two ordered pairs, 2 points in other words. I have point A and let's say I have point B. And let's say point A has coordinates x1, y1, x sub 1, y sub 1. It's my first point. I'm going to denote them by x1, y1. And what do you think I'm going to denote the coordinates of point B? Of course, makes sense. I'm going to connect these two, and I'm going to call this line segment, the length of this line segment, D. Bless you. As if, and because it's the distance I'm looking for, the distance between A and B. Okay. So now I'm going to ask you to form a right triangle with me by drawing a parallel line to the x-axis and a parallel line to the y-axis. And then I'm going to ask you a couple of questions here. How much is this distance? And then I'm going to ask you how much is this distance. And of course, what I'm interested in is this distance. And I'm going to do the same here. How much is this? How much is this? But basically, I want this. So look at the point. The point has coordinates x1, comma y1. So what does this equal? The point has coordinates x1, comma y1. How much is this distance? 1. Exactly. Of course. Absolutely. This must be x1. Okay. What is this distance? Of course. What I'm interested in is in this. So what is this distance? Excellent. Wonderful. Absolutely. So if this is x2 and this is x1, this must be x2 minus x1. Very good. Well done. Okay, perfect. So now I want the same thing for the other one. So I want you to tell me how much is this? Excellent. What is this? And now what I'm interested in is this. Very good. So stay with me, please. So I'm going to draw this triangle one more time. Right here. I have this D, I have this x2 minus x1, I have this y2 minus y1. What do we know we can apply, maybe a theorem that you remember that we can apply in any right triangle? What is it called? The Pythagorean Theorem. Excellent. Thank you very much. Very good. So let's apply it. I don't want you to say what you probably were taught in high school. I don't want you to say a squared plus b squared equals c squared. No. I want you to say the sum of the squares of the legs must equal the longest side squared. Because if I change the notation, how will you know which one is A, which one is B? So I want you to say the sum of the squares of the legs equals the hypotenuse squared. And I want you to apply it for the notations we have here. So tell me what to write. The sum of the squares of the legs equals the hypotenuse squared. What is the leg? One leg? x2 minus x1. What is the other leg? And what is the hypotenuse? Exactly. This is what we have to remember. Not a squared plus b squared equals c squared. Because you have to show what is a, what is b, and what is c for the theorem to work. So always remember it. The sum of the squares of the two sides that form the right triangle will always be the longest side squared. Okay, excellent. So then, this is the distance. So d squared equals x2 minus x1 squared plus y2 minus y1 squared. I just reversed it. But I'm not interested in d squared. I want d. What should I do to both sides? We just did that with two problems. What should I do to both sides to get d? Take, not square, but take the square root or apply the square root. Very good. So I apply the square root to both sides. So then d must equal, what should I write? What did we say? What did we just put on those three problems we worked on? What did we write? After we took the square root, what did we write? We wrote plus or minus. Is there any point in writing for this particular example plus or minus? Should I or should I not? Of course, in this particular case, I have to omit the minus because it's a distance. I can't say the distance between me and Heather is negative 20 feet. So this is one time in which I will not write plus or minus. Can I simplify this? The answer is no. Remember what we talked about last time. We said that we cannot take the square root from a sum of terms. Here's what we wrote. This is a sum of two squares, right? I'm not allowed to take the square root from this square plus this square because it will never equal this, right? So then, this is it. S is. I cannot touch it. I cannot do anything to it. This is the distance formula. No one can simplify it. Now, I would like you to, if you want, we can work on these 2 points, or you can invent 2 points that you want to work on. Before that, I'd like to show one more thing. And then we'll look at problems. So here's what I wanted to show. There is a point right here, denoted by M, midpoint, that bisects, we say, or divides the line segment into 2 equal parts. The coordinates of the midpoint, the coordinates of the midpoint are the average. What is the average of 2 numbers? You add them up and you divide by 2. Exactly. The average of the x values, comma, what do you think the y coordinate will be? The average of y values. So now let's pick 2 points, or if you want, we can work on these points given in that I put on the handout, in which we will determine the distance and we will determine the midpoint. If you don't like those, invent 2 ordered pairs. Just give me what you want to work on.